All right, let's look at our counterexample foldable. This is, if you care, this is section 2.2. We're not doing the entire section 2.2. This is kind of the only thing we're taking out of it. So a counterexample is just an example that shows that a statement is false. Before we get into that, we need to talk about truth value a little bit. So a conditional statement can have a truth value. And by truth value, I mean, is it true or is it false? Okay, it's no, well, sometimes it's true, sometimes it's no, it's either true or it's false. So a conditional statement can have the truth value of true or false. Now, to show that a conditional statement is true, you must show that every time the hypothesis is true, the conclusion is also true. So a conditional statement can be true 5 million times, and if it's false one time, it's considered a false statement. Okay, so if we're trying to show that a statement is false, all we have to do is show that one time there's one example out there that makes this false, and the entire statement is false. All right. So to show that a conditional statement is false, you need to only find one example for which the hypothesis is true and the conclusion is false, which is kind of what a counterexample is. All right, so let's look at this example. If it is not a weekday, then it is Saturday. Okay, we want to show that this statement can be false. Okay, and the way we do that is we have to show one example of when the hypothesis is true and the conclusion is false to show that this entire statement is false. Okay, so when would be an example when is it not a weekday, but it's not Saturday. So the hypothesis stays true. So we still want it to not be a weekday, but we don't want it to be Saturday. Well, it could be Sunday, right? Is it Sunday, not a weekday, and it's not Saturday? So this would be a counterexample of the above statement. All right, let's look at another example. If you live in a country that borders the United States, then you live in Canada. Once again, this is a false statement. So we want to find a counterexample. So we want to find one example of when the hypothesis is true and the conclusion is false. Okay, we're not writing this in an if-then statement. We just want an example of when the hypothesis is true and the conclusion is false. So think about it for a minute. So when do we live in a country that borders the United States, but it's not Canada? Well, guys, there's one other country that borders the United States, and it's Mexico. So you could live in Mexico. Okay, that would be a counterexample to this statement here. We could live in Mexico. Last but not least, the formal study of logic, and that's what we're doing. We are studying logic now. Considers errors in reasoning called fallacies. Okay, so a fallacy is just a time in logic when our reasoning is false, when we make a mistake when we're trying to do our reasoning. We won't use that word a lot, but it is kind of a big deal when it comes to logic, so our book does kind of present it to us. All right, let's look at some examples of counterexamples. That's funny. All right, so we're going to just do 4 examples, and we're going to cut this off from the sheet we just did, and we're going to put one sheet on one page of our interactive student notebook, and then this page on the other page. And guys, when I printed this, for some reason I printed the wrong copy, so there should be an x squared here, and x. So this on A, it should say the value of x squared is always greater than the value of x. Now remember, in order to find a counterexample, we have to find an example of when this statement is false. Okay, now sometimes when we try to find examples, we don't find an example on the first time. All right, so let's just say, I don't know, let's let x equals 4. Who knows? Just throw out a number, x equals 4. All right, so the value of x squared is always greater than the value of x. Okay, so x squared, so 4 squared is greater than 4. 16 is greater than 4. That is a true statement. Okay, so that would help us prove this statement is true, not help us prove this statement is false. So that won't work. Let's try a negative number here. So how about x equals -4? Okay, so if x equals -4, is the value of x squared, so -4 squared, is that greater than 4? Well, -4 squared, remember, a negative times a negative is a positive, so that's 16. Is 16 greater than 4? Yes, it is. Well, that's a true statement, so that's not helping us. All right, so what other things do you think that we could use to prove this statement false? What haven't we used yet that we could still try? All right, let's try a fraction. So let's try when x equals 1/2. Okay, so if the value of x squared, so x squared is greater than the value of x, which in this case is 1/2. Well, guys, 1/2 squared is just 1/2 times 1/2, which is 1/4. So 1/4 is greater than 1/2. Is that a true statement? Is 1/4 really bigger than 1/2? If you're having problems thinking about it, think of it as like a pie. Is 1/4 bigger than 1/2? No, it's smaller than 1/2. So this statement here is false. So this would be our counterexample because it shows that this statement is false. So when x equals 1/2, this statement is false. So that would be a counterexample. All right, let's look at B now. It says the sum of two numbers is always more than the greater number. Okay, so I don't know, let's just put two numbers. So let's do 5 and 3. So the sum of two numbers, remember sum is we're adding them, is always more than, so this is going to be greater than the greater number. So a 5 and 3, which one's greater? 5 is the greater number. So is 5 plus 3 greater than 5? Well, A is 5 plus 3 is greater than 5. Yes, that's a true statement. So this would not be a counterexample. Remember, counterexamples help prove a statement is false. This is actually helping us support this statement somewhat. So we are not going to use that. Okay, so what else could we use? I don't know. What about, let's make one of these negative. So let's make this a -5 plus 3. Is that bigger than the greater number? Well, the greater number here, guys, -5 is less than 3, so the greater number is 3. Well, let's look. -5 plus 3 is -2. Is that greater than 3? No, -2 is not greater than 3. So this would be a counterexample. This example right here proves that this statement is false. All right, let's look at C. Now, this is a non-math example, so some of you might actually like this one better. It says, anyone who lives in Augusta must live in Maine. Okay, so what would be an example that would prove this statement false? Well, couldn't you live in Augusta, Kansas? That would prove the statement false. Anyone who lives in Augusta must live in Maine. No, you could live in Augusta and live in Kansas. So that would be an example. All right, let's look at D. This is the last one of our examples. It says a rectangle with an area of 16 inches, or 16 square inches, must have lengths of 2 and 8. So I want you to think about it and come up with a counterexample of when this statement is false. All right, guys, there's several examples we can do here. Remember, to find a counterexample, our hypothesis has to be true. So it has to have an area of 16 inches. Okay, but our conclusion is going to be false. So it won't be 2 by 8. Okay, well, couldn't it be, I don't know, 1 by 16 or 4 by 4? I don't know. I'm just going to put 1 by 1 inch by 16 inch. That would be a counterexample to show this statement is false.